All right, so now we want to look at this idea of a difference of two proportions. And again, I'm going to show that, well, you don't have to quite think of it this way. You can think of it as looking at the independence between two variables. And so now we will have kind of a P1 and a P2. So this is still section 3.1. Or, oh wait, is that 3.1 or 3.2? 3.2! Sorry, section 3.2. And we want to look at this idea of a difference of two proportions. And we'll start with the idea of the confidence interval. For this idea, though, what happens is I have, say, two proportions that I want to check against each other. So a very typical kind of thing you might do is like a before and after. Okay, so right, what you do is you maybe are trying to assess how well your program is working. It might be some sort of education program. It might be some sort of rehabilitation program. It could be a surgery, right? After you do surgeries, how well are people doing compared to before? That kind of idea. And so here you often in a lot of these particular before and after cases, although it wouldn't have to be, it may be you're looking at the same people or the same item. It could be a manufacturing sort of thing. And so, for instance, one of my daughters is in the manufacture of health supplies, hospital supplies, that kind of thing, and so they might look at how well something does before it's treated a certain way, and then how well it does after it's treated a certain way, and so that's before and after is a very typical kind of thing. And so what might you have, and you might still have these successes and failures, right, before and after, and so let's just set that up that way. Here's what my data might look like. So here's success, here's failure. Something like that. And so it could be, I'm going to let people try, well, we can go back with the free throws, why not? We can milk that for all it's worth, right? So it could be that I have either a single person or a whole team or something like that do free throws, and I just kind of check where they are. They come in first day of practice or something like that, and I look at where they are, and maybe they're able to get around 60% or something, and so let's say they got 32 out of 50. So here's our totals, and so that would leave 18 for failures. And then we have them go through a series of drills, maybe work with their stance, maybe work on concentration, maybe have them do some yoga, but we work on something, and after we do that, we see that we get 39 out of 50, and so 11 here. And so I could also get these sums if I want. So what is that? 71 and 29. And total, they make 100. Okay, and so the question is the before. So if we call the before p hat 1, that's equal to 32 over 50, which is 0.64. And then if we have our p hat 2, the after, that was 39 over 50, and that's equal to 0.78. And so the obvious question is, are they different, right? Did we actually impact the team somehow, right? So the research question is whether practice impacted the team. And as I mentioned, we're going to look at confidence interval first, and so the way the confidence interval works is we're actually going to look at the difference. Okay, so here and I think this is something very important to notice is that here we're going to talk about the difference. Let me go back up here. Difference of two proportions. In section 3.1, I talked about a single proportion was really two proportions. Well, okay, that's for a given success and failure. Here, we're looking at the difference of two proportions. Okay, and so actually, in that difference of two proportions, there are a total of 4 different proportions here, right? Before successes, after successes, before failures, after failures. Okay, so it's just kind of keep in mind that a lot of words are very similar. I mentioned two proportions, but now in 3.2 we're trying to decide, is there a difference in the two proportions? Now, so as we look at that, right, another way to ask that, is there a difference in the before and after proportions? Then another way to look at that is there a difference in the relative proportions of these two columns? And so I can think of the whole column instead with the 32 and 18 and the 39 and the 11 and ask, do I think these two columns actually just came from the same population, but because of sampling they look different? Or do I think these two columns probably came from different populations? Okay? And so that's another way to kind of frame the question. And we call it a difference of two proportions in this case because in order to get a confidence interval, that's what we do. We take the difference. Okay? So here we could take, I think I'm going to go with P2 minus P1 for that confidence interval, just because I have the bigger number here. So I'm going to look at P2 hat minus P1 hat, and that is 0.78 minus 0.64. And that's equal to 0.14. And once again, the whole idea is this is an estimate of the actual difference of the population. Okay, that's an estimate. And so we want to do that same sort of thing is, here's the real population. So this would be like P2 minus P1. And we had our data out here of P2 hat minus P1 hat. And so once again, we can think of, well, if this is the actual population, we could think of 95% of the population is in here, 0.025 out here, 0.025 out here, this is 0.95. And now, again, just like before, if I can take this size interval, the plus or minus 2 standard deviations or 2 standard errors, and I can, slide it over to be centered on here, then again, 95% of the time, I have the right answer, whatever it is, inside that interval. And so, well, if I've got an interval, then, I don't know what the right answer is, but in some way, I've got this 95% confidence that I kind of know about where it is, right? I can draw that confidence interval around it. Okay, so that's what we want to do again. And so it is our P2 hat minus P1 hat plus or minus 2 standard errors. And so the question is, well, how do we calculate that standard error? And they, in the textbook, let me switch to the textbook, they give us actually a couple of ways. So here, so here they're saying, okay, we can calculate that standard error this way. Difference in sample proportions is, and they write it this way. And you notice it's really similar to our single sample proportions and standard errors. We just add these two things together, the P1 times 1 minus P1 over N1 and the P2 times 1 minus P2 over N2. So that looks just like what we did before, but we're adding them together, and then we take the square root of the whole thing. Okay, now, so that's one way to calculate it, but I think, and actually I could be wrong here. Maybe I'm thinking of means if there's a, oh, here we go, yeah. I thought they had this in here. So they say, oh, here's also a pooled estimate. And they say, oh wait, let's go back up here. Somewhere, let's see. They're talking about the dogs. Okay, let's see. So okay, they're using the regular standard error that they suggested. Okay, and then they say something about the exposure rate. I don't remember exactly what this example was talking about. Oh, exposure is that the proportion of dogs with exposure to 2,4-D, so something or other, is the same in each group. Okay, and so they talk about that, and then they go to this pooled estimate, and And this is a different estimate for the standard error. It's not way different, but it's a little bit different because here they're using the total number of successes and total number of failures. Okay, so if we go back here, oops, I gotta hit that a couple times to bring it up. So for here, that pooled estimate would say that we take the 71 over 100 and the 29 over 100 for our p and 1 minus p. Okay, and so they would say for a pooled estimate, we're going to use 0.71 times, right, I did have that right, 71, yeah, and 29, so 0.29. 0.29 over 50 for that one. And now, because these had the same numbers, these look the same, 0.71, 0.29 over 50. But we're going to use the pooled estimate to do this standard error. Okay, and so when we do that, we'll get our standard error. We'll look at this, but again, well, let's go to confidence intervals for two proportions with Desmos. I'll click on that. And okay, so confidence intervals for two proportions. It says remember to adjust successes, failures, and n. Okay, so we had, I have to look back at it here. We had 32 successes and 18 failures for a total of 50 for one of our cases, and that was the before, and there's our 0.64. And then our after was 39 successes with 11 failures, and that was for a total of 50. And there's our 0.78 for that one. And now this did P1 minus P2. It always just does P1 minus P2, so it gave us a negative of 0.14. But so there's the center of our confidence interval. And then here, notice it's doing the standard error. Oh, okay. Well, according to this, it is not using the pooled estimate in this case. I thought it did. It doesn't really matter. Now, in this particular case, the pooled estimate, oh yeah, it wouldn't be the same. Never mind. Okay, so we get a standard error of 0.08, and then when they take the 2 times, or 1.96 times that standard error, and here's our confidence interval. Okay, and we look here and we can see those dotted lines making our confidence interval, and it goes from minus negative 0.32, I'll say, to 0.04. Okay, so when we do this, we get our point. I messed up in that I used P2 minus P1, and that thing uses P1 minus P2, so I'll use their negative 0.14, and then plus or minus, they had 1.96 times something or other, I don't remember, but that gave us our confidence interval from minus 0.35-ish, I think, up to 0.04-ish. Okay, so there's our confidence interval as to what the actual difference is. Now notice 0 is in this interval. Oh, interval. There we go. And so that means if I'm asking, did they improve, right? Now this is just a confidence interval, but according to the confidence interval, a perfectly reasonable answer is that these really did come from populations with no difference between those proportions. So in other words, there is this possibility that there was no improvement. Okay, so we'll get a p-value on that with a hypothesis test, but that's the idea of creating a confidence interval. And usually with the confidence interval, for this difference of proportions, we do try to notice whether 0 is inside the interval, because if 0 is in the interval, it would mean that P1 is equal to P2 is a possibility. Okay, it means that it is a possibility. Oh, and I would like to know that. And if 0 is not in that interval, then it's the confidence interval saying that, yeah, probably these two proportions were different. We always say probably because it's all based on random stuff. But if 0 is not in that interval, then yeah, probably the difference is not 0. But here, at least there is some possibility, certainly within this confidence interval, that the two proportions were the same, and so there was no improvement. Bummer. Okay, so we'll also look at this example with a confidence interval. Okay, so we'll call that one done.